Okay, so welcome to the day 4 of translating word problems. So this is our last one. It should be a short little lesson here. Um, so we've seen money, or there's tickets or coins involved. We've seen numbers. There's two numbers, you have to find them. We've seen investments and food mixtures. And so this leaves us with our last one. We're looking at distance, speed, and time type scenarios. Okay, so you might see this in physics, in physics and so forth in the future. So it's a good one to kind of get an early look at. Okay. All right, so we're going to start with a submarine here. It can travel up at the surface of the water, or it can travel underneath the water. We have some information about how fast it's traveling. So again, you see signs when you're driving with your parents, kilometers per hour, right? So this is the submarine can travel 16 kilometers per hour at the surface, 10 kilometers an hour under the water. So if the submarine travels a distance of 160 kilometers in 12.5 hours, how long was it under the water? Okay, it asks for how long it was, underwater for, but there are a couple scenarios here. There's when it's at the surface as well. So let's just approach this question like we have to find both, and then when you do actually do your therefore statement, you just state the underwater time. So, all right, so we have the surface. And you have underwater scenarios here. Okay, so I'm going to label them X and Y. Okay, so what do the X and Y in this scenario represent? So we have how long did it take? So that's going to be our time. Okay, and so if that's our time, it told us the total time that it took for this journey, so it was 12.5 hours. Okay, so we know that much. All right, what else do we know? We know that the speed that it was traveling at, so we'll label that up here, speed. Okay, so at the surface, it could travel 16 kilometers an hour. So if you want, you don't have to write the units, but you can if you want. Because in this one here, we're not going to build the equation. So anyway, if you want, you can leave it without. So anyway, we know that 16 kilometers an hour is how fast it can go at the surface of the water, and 10 kilometers an hour for when it's under the water. And then from there, it talks about if the submarine traveled a distance of 160 kilometers. So that's another factor here, right? So distance. Okay, so we don't know how far they traveled at the surface and how far they traveled when they were underwater, but we do know the total was 160 kilometers. Okay, so we have a scenario here. Well, we knew enough information about the time to build an equation. So we know time spent at the surface was X, the time spent under the water was Y, altogether it's 12.5. So I'm just going to give myself a bit more space here. So I just want to show you how speed, distance, and time are related to each other. So right now we'll start off with speed. Okay, and so with speed is distance over time. So if you actually look at the units kilometers per hour, okay, so that's the same as writing it like this, kilometers per hour. So you're finding that the kilometers, which is your distance, is at the top, and then hours, the time, is at the bottom. So you have, to get speed, it's like you take the distance and you divide by time, and then you'll get the rate, the speed that you're traveling, okay? So that's how you would find speed. So if we were to rearrange this and figure out, well, how would we find distance, which is what's missing here? It's just you should know how to solve these. You should, to kick the time over there. And so it becomes speed times time. Okay, because right now time was divided by distance. So if we move it over here, it becomes multiplied by time. So in order for us to find distance, you need to take, so if you want to have distance here, you need to take the speed and multiply the time, and that's how you can find the distance, okay? So in general, speed, you take the distance divided by time, but if you already have speed, but we need to find distance, we're going to move the time over and multiply it by speed, okay? So if it helps, I can provide this formula for you and provide that formula for you as well, but I just want to explain how we got to there. So in order for us to find the distance that it traveled at the surface, you're going to take the speed that it was traveling at and multiply it by the time. So x is the time that it spent at the surface. All right, and for underwater, the speed was 10 kilometers. So we're going to multiply speed by the time, which is y. Okay, and then altogether, when you add these up, it traveled a total of 160 kilometers in the water. All right, so sorry, I went right into building the equations. I forgot to state my variables here. So back here, we decided that x was going to represent what? The time that it spent at the surface of the water, okay? So let's just shorten this surface time, okay? But if you want to write time spent at the surface of the water, that's fine too. So surface time, and then do we have any units here? Yes, so if you're kind of scanning through, everything's in hours for the time. And y is the underwater time. And again, units of hours. Okay, and then we're going to always build a couple equations here. We'll build a time equation and we'll build a distance equation, but we're going to have our speed assist us to get to distance. So the first equation that we'll have to tackle this problem with is the time equation. So we know it took 12.5 hours altogether, and then the distance is speed times time, and speed times the other time. So for a total distance of 160 kilometers. Okay, so that's it for the distance, speed, time type equations, okay? We're going to do another one, but hopefully, it's quite related to the money questions and stuff like that you've been doing. Just, it's a different scenario, and that's why, I recommend try to use these boxes here because it really organizes your work and your thoughts, and then you can build your equation, okay? All right, let's go to the next one. All right, do I have enough space? Yeah. Okay, so we have someone traveling to Montreal. Okay, so taking a scenic trip from London, Ontario to Montreal, Quebec. Okay, so the total distance for this scenic trip, so they didn't go straight there, they kind of went around and stuff, 830 kilometers. So she traveled part of the way by bus, the rest of the way by plane. The bus averaged speed of 40 kilometers an hour. So again, kilometers per hour. So you're seeing the units, so that's how you know it's speed. The plane went at 500 kilometers an hour, okay, average. So the whole trip took 3.5 hours. How many hours did she spend traveling by bus? Okay, so just like up here, it only said, oh, how much time did they spend underwater? I want you to still go build both. Find the surface and the water, okay? So here, they just want to know how long she took on the bus, but let's find the bus and the plane. Okay, so here we go, fill in the table, bus, plane, okay, and then again, once you get really good, you don't have to fill in this table. You don't even have to use it, okay? But again, just at first when you're learning how to do this, it will help you focus and so forth. Okay, so we're looking at so the bus and plane, we're just going to set it as x and y. So what does the x and y stand for? Well, we're trying to find this time spent. Okay, how many hours did she spend traveling? So that's your time that you're developing here. So let's set those variables. So x will be time on the bus. So we call it bus time. Bus time. Yeah. Bus travel time, maybe more specific. Bus travel time. Okay, and those units are hours. and y will be the plane travel time. Okay. So from there, we're going to use our table to list off some, actually the total distance. Oh yeah, so yeah, we'll go through and list off the speed, and the other one will be the distance. Okay, and if you want, you can just write T, S, and D, I guess, as well. All right, so the speed for the bus was 40 kilometers an hour, okay, and the plane was 500 kilometers an hour. And we know that the total distance traveled, so you can even like say total, this whole row here is total. So the total distance was 830 kilometers, and the total time for the whole trip was 3.5 hours. Okay, so you know to add these to get the time. Speed, we don't add the speed up just because depending on what part of the trip it was, we had a different speed. But we can measure the total distance, okay? All right, so, but we just don't know how to represent that yet. So what we're gonna do again is, just a reminder, distance, to find that, you take your speed and you multiply the time. Okay, so 40 times x is the bus distance, and then the plane is 500 times y, that's the plane distance, and for the grand total of 830 kilometers. Okay, all right, so fill those equations in. So you always make sure like you can kind of do your work kind of over here on the side, but then you want to clearly always state what your answer is, okay? I have students, sometimes they go in a circle like this trying to figure it out because they're brainstorming, and then they hand it in. I don't know where the answer is. So just get in the habit of, once you kind of finish your brainstorming, clearly show your answers in a space where I can see it, okay? So in general, if you're wondering what a question would look like when you're going through a test or assessment, I would just give you the problem here. I wouldn't give you the boxes, okay? Unless, I don't know, unless you really want them. But it's there just to kind of get you set up, remind you that you have to find variables always in equations, and then you're going to go through and actually solve it too. But yeah, like normally teachers won't give you this part here as a guideline. So just know to kind of just go ahead and do this on your own, okay? All right, that's it for all of those word problems. So hopefully you can go and do the checkpoint now, and then for the next day, we're actually gonna go through and finish these off and actually find the answers.